Hello everyone! In today's video we are going to discuss recursion and provide first easy example in Java. Recursion is the process in which a method calls itself continuously until this certain condition occurs. In some situations recursion, when done correctly, can be efficient and powerful. But like many other things, recursion also has its advantages and disadvantages. Advantages are that it can offer short code and readability. It can solve problems which are naturally recursive, for example Tower of Hanoi, which we will see in our next sessions. Disadvantages are that it can be slower, sometimes it can overload stack because multiple method calls are accumulated on the stack, and also recursive logic can be hard to understand, especially if you're a beginner. Now let's see the example about recursion. In this example, I have the method named Factorial, which takes an integer as an argument and it also returns integer. Then we have this if statement which checks the value of this n. If n is more or equal to 1, we enter this statement which says return n times factorial n minus 1. Otherwise, it will return 1. Now let's see what happens with the actual value of n and analyze the workflow. So if we have the value 3 passed as a parameter, we see the if check, so n is more or equal to 1 because now n is 3, and we enter here in this statement. We see that there is a method call. Now we are calling factorial method from the inside the method. So this is called recursive call of the function to itself. Recursive means that function is calling to itself from inside. And now it says factorial of n minus 1. This recursive call will be executed as many times as necessary until the breaking condition will be reached. So what happens if n will not be more or equal to 1? Let's say n becomes 0. Then we go to else block, and else is the breaking condition because it prevents the method from calling itself again and again. So when we enter else, we return 1 because mathematically the factorial of 0 is 1. So after we have this value 1, let's see what happens on the stack. So at the first place we needed factorial of 3, which is 3 times factorial of 2, but factorial of 2 was unknown. Then we needed factorial of 1, and factorial of 1 is 1 times factorial of 0. And finally, when we pass this 0 as a parameter to this method, we can see that 0 is not more or not even equal to 1, and we enter this else block. So we get the value 1. So factorial of 1 will be 1 times factorial of 0, which is 1, so it will be 1. Then factorial of 1 will be 1 times factorial of 0, and it is still 1. Then factorial of 2 will be 2 times factorial of 1, which we already know that is 1. So 2 times 1 is 2. And factorial of 3 will be 3 times factorial of 2, which we can see that is 2. So 3 times 2 will be 6. So this process is called unwinding. When we are entering the breaking condition, we get the value 1, and we are inserting this value into different method calls which we called previously. And we are inserting this value into method calls which were accumulated on the stack previously, because we did not know what was factorial of 3 or factorial of 2 or even factorial of 1 until we entered into this breaking condition and returned the value 1. Now let's visualize what happens on the stack and how method calls on the stack look like. So this is a call stack. As you know, on the stack there are multiple things on top of each other accumulated. In our case, these things are method calls. So this is the initial method call, which is down to bottom, and then next method call, which was factorial of 2, will be on top of it. Then we add factorial of 1, And finally, we have this factorial of 0 method call, which actually finds the value 1. After this, as you know, stack is last in, first out, so last call will be popped up with the value. Now the next one, factorial of 1, will be known because we know already what factorial of 0 is, and it will have its value. Then the factorial of 2, and finally we will find out the value factorial of 3, and it will be popped up with the value 6. So 6 will be returned after all of these executions. Now let's create a coding example about factorial. So let's right click on this package com.recursion demo, create new class and call it factorial demo. Inside the class, let's have main method from which we call our factorial method, and let's declare factorial public static int factorial, and let's pass the argument, let it be of type integer and call it num. Inside the braces, let's check if num is more or equal to 1. In this case, we say return num times factorial of num minus 1. Otherwise, we will have our breaking condition in else block. In this case, we still do not need to use curly braces because there is only single line. We return 1. Let's test this method. So we say system out println and inside it factorial, and let's try for 3. Now let's hit run. Method will run and we can see the result 6. Now let's debug. So move your cursor here and let's choose debug factorial demo. Now we can see the value 3, which is passed as a parameter. Then we can click to step into and see the execution. Method just called itself and now num equals 2. We can click step into one more time. Still we can see method called itself. Now the value is 1. And finally method still called itself, but now the num equals to 0. So you can see multiple method calls on this tag, like we discussed and like we saw on the example when we tried to visualize these multiple method calls on this tag. So this is actually what happens here. These are multiple method calls accumulated, and we see that when num was 0, we entered to else block and 1 gets returned. So if we click step into, we can see that these methods are popped up from this tag. And finally, the value gets returned. This was all about recursion example using factorial. Thank you for watching, and I will see you later.